Hey, so nowadays computer has multiple cores, and did you ever astonished with how the processes are assigned to the cores? So in last video we discussed about how single core handle all the processes at the same time. So if you want to get more understanding about this, please go through that. It might be coming in suggestion somewhere up. Okay, so operating system is the one who gonna assign the job to each core, but how is dependent upon how the cores are mounted in our computer. So there are two ways, like, so each core can have a separate chip, or every core is mounted on the same chip like this diagram, so having a common queue. And then we can check it like this. So operating system is the one who gonna push all the processes to the queue, and the core's gonna pull it from the queue as soon as it become available. So every hard work is done by cores, queue, operating system, and we as a user is just happy because everything is happening so efficiently. And now the cores with the separate chip like this, then they have different queues, so there needs to have a load balancer task who gonna check the balance among the queues, so that every core gonna get equal amount of work. Because you pay more to buy more cores, then it's a normal expectation that your computer should perform very efficiently. Then it's computer's responsibility that it should make most out of it. So that means that it needs to balance the task among the cores, which mean that each core should get enough amount of work, or we can say it should be distributed evenly. All right, so internally there is a scheduling algorithm. So if you check out my previous video, which will explain it a bit more. So for example, we can talk about that each process will get some time to be executed by each core. So let's say there is a fixed quantum or a fixed time slice that each core will give to each process. So for example, here you can see that we have three cores and we have six processes, and three are waiting in the queue and three are already assigned to each core. So these are the running processes. So another are just waiting, so they are active but not running. Cool. So next we see that, so P0, which was processed by core 1 for some quanta, but that is not completed. So that's why it is again in the queue waiting for its turn. And other processes are assigned to other cores, and P4 or and P0 is waiting now. So the problem is, like, if you see in the previous one, so this P0, to run this P0, we definitely need some data to be loaded in core 1 by that can be used by this P0. So when the P0 is not there and the data is still in core 1, and it totally depend upon, like, now P0 will go to which core. So because data is associated with P0 is still in core 1. So if we see in the next one, so P0 is assigned to core 3. So which means that it needs to load all the data from this core 1 and to core 3. So which is very expensive process to do. So that's why there is a term called affinity comes in. So affinity is basically that I want to live with you as long as I live in the world. So basically each process needs to be assigned to the same processor every time when it needs to be executed. So there are two variation of affinity. One is hard affinity and the soft affinity. So hard affinity is that scheduler will ensure that this process will definitely go to this processor. It's sort of guarantee. But in soft affinity, scheduler will try to do that, but it is not like always feasible. So if let's say core 1 is busy for a long time, then scheduler will definitely assign that process to another core. Okay, so that's it for this video. Thanks for watching. So please share, subscribe and like. Bye bye.